Welcome to my talk at the 2020 Spinnaker Summit. This talk's titled Spinnaker Plugins by Example. I'm going to walk you through how to write plugins and show you a couple different example plugins. This is a slide where I try to convince you that I'm an expert in my field and I'm a pretty cool guy. Up at the top left, that's me with my family. Currently work at Armory on the extensibility team, and we've been doing a lot of work on plugins with people at Netflix. And I actually used to work at Netflix back when Spinnaker was just getting started, and I even worked on the precursor to Spinnaker, Asgard. When I'm not spending time with my family or writing code, you'll find me on a wakeboard or doing jiu-jitsu. In this talk, we're going to go over where to find good examples of plugins. We're going to look at 3 of them. The first one's going to focus on extending with extension points. The second one's going to talk about how to extend behavior in plugins using Spring, mainly for when you don't have extension points. Then we're going to show a cloud provider plugin, and we're going to talk about some of the improvements we're making to the Spinnaker platform to allow more powerful plugins. So this is a GitHub organization we've got called Spinnaker Plugin Examples, and we've got several. I'm not sure how many we have now, but it's more than the 4 that's just showing on the screen right here. These are all public. They're basically meant to be good examples that you could look at to start your own plugin based on one of these that's similar to what you want to do. And for us, they also prove out that functionality in the plugin platform works and continues to work. So these are the 3 examples we're going to cover. The first one is the stage plugin. This is an example we use a lot. This adds a new pipeline stage, like custom pipeline stage using extension points. The second is just a example of using Spring to build out a plugin, and doesn't do anything useful, just shows off the Spring plugin capabilities. And the last one also uses Spring, but to do something useful, we implement a new cloud provider, one for Nomad specifically. All right, so here's our first plugin example, the stage plugin. So if we look at the overall project structure, you'll see that there's all the backend projects are Java based. There's a Gradle build that builds everything, and there's sub-projects in here. You'll see the random weight deck and the random weight orca there, and these plugins can target multiple services at the same time. That's the parts that get deployed to those services. We typically have a suffix on those submodules that reflect the service that they're to be deployed to. So this is just an overview of the specifics in the Gradle build files that are noteworthy for plugins. On the top, this is the build Gradle that's just got metadata about the plugin, the ID, description, version, and we also have compatibility tests defined that run this plugin against different versions of the Spinnaker platform. At the bottom, you'll see the random weight orca Gradle. This is the Gradle file that's under the orca submodule. And here you can see how this plugin works specifically with orca and the dependencies that the orca component uses. I've also linked in the bottom left to a short video I've made previously that goes more into depth about how the Gradle build works in our plugin projects. So you'll see something like this on all of our plugin examples, and this basically tells you the standard way of using plugins in a Spinnaker project, and we give an example of the configuration for the specific plugin. So that configuration is YAML. It will go in the Spinnaker service config, and we just call out what plugins are used by ID. They're enabled, and under that, there might be specific configuration for that particular plugin. So this is the entry point for our plugin project. You extend plugin, and you get lifecycle hooks for start and stop of the plugin. Here, we're just logging that it starts and stops. So in this plugin, we have extensions where we implement new stages and tasks. This shows our task extension. So a few things to call out here are our use of the extension annotation that lets us know that we're extending an extension point. Over on the right, you can see that we're extending task, which is an extension point. We'll look at that in a second, but it's basically just a Java interface. And then task has an execute method that we implement, and that defines the behavior for this task. You can see where we're passing in the random weight config, and that's actually coming from the configuration, the custom configuration for this plugin that we were just looking at. At the bottom, you can see that random weight config and the default max wait time that we saw defined earlier, and that's annotated with a plugin configuration. So what is task? What are extension points? Well, the extension points live in the API submodules of Spinnaker services. So you can see task coming from Orca, the Orca API submodule. Extension points are basically just Java interfaces. They also have to extend Spinnaker extension point. You can see the task extension point defined in the bottom right. Plugins and extension points are concepts that come from PF4J, and that's a library that powers our plugins. It helps us do useful stuff that we would have had to write on our own for customizing behavior of an existing project. One of the nice things that it does is give each plugin their own separate class loader. So these are some of the current extension points across the Spinnaker projects. These projects have API modules, like the Orca API module you saw before. Of course, here we're talking about the task extension point in Orca. That example also has an implementation of stage definition builder, and we're adding more extension points all the time. So what if there's not an extension point for the behavior you want to add to Spinnaker? Well, there's a couple of options. You can make one now that you've kind of seen how it works and contribute it back to the Spinnaker services, or you can use Spring to extend just about anything you want. So here's our second example, the Spring example plugin. Over on the right, I list a lot of Spring things that this example tests out. But it's basically, if you're familiar with Spring, using a lot of the Spring annotations to wire everything together. We're going to look at several of these in detail. So it all starts here. This is similar to the entry point for plugins that you saw earlier, but instead of extending plugin, we extend Spring Loader plugin. We have the same start and stop lifecycle hooks, but we also have this get packages to scan method that we can override, and we give it a list of packages. And it's going to scan those packages for Spring components. So properties are done a little differently as well. Configuration properties is a Spring annotation that we're making use of here, and the properties can be anywhere you want them to be in the config YAML. Here you can see that we're pulling new properties from the root. Component is a Spring annotation that will load this class as a bean. This is a good time to mention that for Spring plugins, plugins have their own isolated Spring context. You can see in the constructor that we're auto-wiring two beans. The first one is a bean that comes from the Orca service. The second one is our properties from our plugin that we were just talking about. Configuration is a Spring annotation that a lot of people are familiar with. This allows you to set up a lot of your Spring components. Beans, a very basic Spring annotation that defines what we're returning from this method as a bean. We're using primary here because it makes this bean take precedence over other beans that are of the same type. Exposed to app is not a Spring annotation like the rest of these. It's our own plugin annotation. And what it does is elevate this bean out of the plugin's Spring context, like we mentioned before, up to the Spinnaker service Spring context. So it puts it in play with other beans in the service. And that's useful in this case because we're making a bean that's going to override a Spring bean from the Orca service. We're replacing an existing Spring bean in the Orca service. We'll look at that next. So this is our override service. And we don't have component or any other annotations on this class because it gets brought in through that configuration we were just looking at. And this is going to take place of the capabilities service bean that's a part of Orca by default. It's going to replace its functionality with custom behavior. Res controller is another widely used Spring annotation for adding endpoints to your application. You can see our new service is auto wired in, and we're adding 3 endpoints that delegate down to the new service. Spring plugins are handy if the behavior that you want to add doesn't have a related extension point yet. Ideally, when writing a Spring plugin, you'll take note of extension points that you wish existed that you would have used. Those extension points will get contributed back to the platform, and the plugin will eventually move over to those and no longer need Spring. Before we talk about the final example, let's talk about cloud providers. So what we mean by cloud provider is a system for provisioning infrastructure, like AWS or Kubernetes or Google's cloud. You can see in the Coulddriver project, a lot of these live as submodules in Coulddriver. Having these cloud provider implementations is what makes Spinnaker multi-cloud. In our third plugin example, we're going to see a plugin that implements a cloud provider. The advantages of this are that the plugin doesn't have to be contributed back into Coulddriver and can be maintained and released on its own lifecycle. The new cloud provider that we're going to implement is Nomad. Nomad's a nice, focused cloud provider from HashiCorp. One of its main concepts is a job that's a specification for what you want to run. Here's the Nomad Cloud Provider plugin. Let's take a look. So this is much like the Spring example plugin we were just looking at. It uses Spring Loader plugin, scans our packages, and let's go look at what it'll find. The configuration works the same with Spring configuration properties. And you can see at the root level of our config, mainly what we're defining here is information about the Nomad environment. In this case, I'm running Nomad locally, and I have it configured for that. The cloud provider interface in Coulddriver is the main entry point for defining a new cloud provider. You implement this to provide the metadata about your cloud provider, and this includes an annotation that we're going to use to annotate all of our operations, and it provides the caching agents. We'll talk more about these in a moment. Account credentials is a Coulddriver interface that allows us to authenticate with the cloud provider. Ultimately, you use these to get some kind of client, whatever you need to interact with that cloud provider's infrastructure and manage the infrastructure there. In this case, we're supplying a Nomad API configuration, which comes from the Nomad Java SDK, and this is what we use to get access to Nomad. You put all of your credentials for all cloud providers in an account credentials repository. So this component reads the credentials in from our properties and populates the passed in account credentials repository. So the way we make modifications to infrastructure in Coulddriver is with atomic operations. This starts with an AtomicOperation Converter. So first you'll notice that we use the Nomad operation annotation that we saw earlier that we stick on all of our Nomad operations. We also use expose to app here to elevate this up to Coulddriver Spring context so that this gets pulled in with all the other atomic operation converters. When Coulddriver gets a message to execute a specific atomic operation on some input, it will look up this converter and use it as a factory to create the description and the actual atomic operation that will be executed. A description validator is optional. First, let's talk about descriptions. This is just a basic Java class that lays out the values used in a particular execution of an atomic operation. Right here, we're just registering a new Nomad job. So we pass in the job and we'll also need the credentials to accomplish that. Beneath that, you can see our validator. The implementation of this simply makes sure that a job ID exists. Finally, here's our actual atomic operation implementation. So you can see we implement Coulddriver's atomic operation. In the operate method, we supply the logic to execute this specific operation, upserting a Nomad job, with the inputs that came in a description. The first line of the overridden operate method has the magic here for registering a new job using the Nomad API client. So that's how we mutate cloud infrastructure. But we also need to read this data in, and caching agents are the way that you do that in Coulddriver. So you'll notice at the top that we implement caching agent and on-demand agent. These don't have to be done in the same class, but it's often done this way. The caching agent allows you to pull on a schedule the data that you're interested in from the cloud provider. An on-demand agent will let you force refresh specific data in certain circumstances. A lot of times, caching agents have a lot of similar behavior given a certain cloud provider. So it's common to have an abstract version of this that's implemented across a cloud provider, and we're about to look at the jobs caching agent specifically in the next slide. So this jobs caching agent extends the abstract Nomad caching agent that we just saw, and all that's really left for it to do is make this specific call to the Nomad client to list the jobs. So now that we can read and write infrastructure data, the next thing to do is map this data from the cloud provider specifics to Spinnaker concepts like clusters, server groups, instances. That's what providers do for us. So here in Coulddriver core, we've highlighted all the providers. Any given cloud provider is not likely to implement all of these, but just a subset that are relevant for that cloud provider. There is a general purpose job provider already, and we're going to implement that. So this Nomad job provider implements Coulddriver's job provider, and it surfaces the Nomad job data that we just got from the cache. These providers are ultimately used by controllers in Coulddriver to surface cloud provider data in a consistent way. Implementing this maps the Nomad job to the Spinnaker concept of a job. So here's an overview of Coulddriver's cloud provider related interfaces that we were just talking about. The entry point to register our new cloud provider is cloud provider. You can see we used account credentials and the account credential repositories to provide an authenticated client. For mutating the infrastructure, we used operations. For reading in the data, we used the caching agents, and we mapped the cloud provider specifics to Spinnaker concepts with the provider interfaces. So it's worth pointing out some best practices at this point. If an extension point exists, use that. These are contracts that are meant to be stable and backwards compatible going forward. If there's not an extension point for what you want to do, you can extend a component with Spring. Ideally, you'd find something in the API submodule. These are candidates for future extension points. It's possible to use something from a submodule if what you need isn't in the API submodule yet, but bear in mind that these are implementation details and could change, and that would require you to update your plugin. So we're currently moving useful classes and interface over to the API modules. Once we get a good abstraction in place, these will get turned into extension points. There's a lot of nice abstractions that already exist in the Spinnaker services. We just looked at several in Coulddriver around cloud providers. Most of what you just saw are now in Coulddriver API, but not everything. At the moment, providers are still in Coulddriver core. So why not just move everything over to the API projects? Well, it's not that simple. We want to put really nice, well thought out contracts in the API module. And the API module is basically a library. So we want to have as few external dependencies as we can there. So if you want to add something new there or take an existing interface and move it over, there's some things you need to do first. First, it needs to be Java, so you may have to rewrite something that's already in Groovy. We annotate it with alpha if it's brand new. Beta or no annotation would reflect that it's more mature. And it needs to have good documentation since it's an API, so we need to put JavaDoc on interfaces and contracts. Existing code may not have it yet. Now we're going to look at adding UI to our plugin. Spinnaker's UI project is called Deck. Our plugin has a Nomad Deck module to add a Nomad UI to Spinnaker. The way that you extend the UI in Deck is a little different than what we've seen with extending backend Java-based services. It's a totally different technology stack. You can see our TypeScript code here. Deck has several registries. You could kind of think of these in the same way that you'd think of extension points on the back end. Each type of registry has its own contract for extension. In this case, we're using the cloud provider registry to add the new UI for the Nomad cloud provider. I'm going to call out a few things that are specified in our cloud provider registry for Nomad. This Nomad server group details getter is the way that we get our Nomad server group data from the backend code that we were just looking at. The server group information section uses React to render the Nomad data that came from the backend. With all that, you end up with this. On the left, you can see the Nomad UI. On the right, you can see the Spinnaker UI with our Nomad plugin that's reading the same Nomad infrastructure. And lastly, these are the links to the open source plugin examples that we just covered. I've given an overview of what these projects do, but feel free to look at them and dig in deeper. Thank you.